So today we are going to use Pascal's triangle to expand a binomial. So what I'd like you all to work on right now is what you see here. I'd like you guys to expand and multiply the following, then try and generalize a pattern to the nth power. So what I mean by that is take a plus b to the nth power and try and generalize a pattern. What you guys are going to find are the coefficients of each one of these expanded are going to be equal to something different. But I'd like you guys to try and generalize the A and the B pattern that's going on. Okay? So go ahead and work on this for a little while, and then we'll get together as a class and we'll come to a consensus on what we find. Okay, you guys, so if you have expanded and multiplied everything correctly so far, then you should have gotten this here. So let's go through here and find some patterns. Let's not worry too much about the coefficients of the A's and the B's, but let's go ahead and think about some of the patterns that we see with the exponents. So one thing I noticed right off the bat is that right here, this corresponds to this is a power of 1. And right here we have a to the first, and then we also have a b to the first there. Over here we have a power of 2, and on either ends we have an a to the first, and then a a to the second, and a b to the second. And if you go down to the third one, a plus b to the third power, here we have on either ends we have a to the third, and we have a b to the third power. Let's try and make sense out of what we have in the middle there. Okay, so one thing that helps me is I think, okay, we have a to the second, and this is kind of like b to the 0 power, and then the next term over we go 1 less than 2 for the a to the second, and we have an a to the first, and then we start going up with the b powers. So 0, the next one we're going to have a 1, and then the next one here we have a 2, and we would have an a to the 0 power here. Anything to the 0 power is 1, so I'm not really changing anything, right? It just might help us come up with some type of a pattern. So this third one here, we could think, okay, well, we have an a to the third next to a b to the 0, and then we go the next term over, we go 1 less than 3, we have an a to the second, and we go 1 more than 0, we have a b to the first power, and then go less than 2, we have a 1, and then more than 1, we have a 2. All the way to the end here, we have an a to the 0 right next to a b to the third. Y'all with me so far? So let's try and come up with a generalized pattern of what's going on without thinking about the actual coefficients. So we're going to say we have a plus b to the n power here. And that's going to be equal to, we're going to say that we're not worried so much about the coefficients right now. We're going to say that's going to give us, we're going to start off with the a to the n power, and then the b is going to be to the 0 power. The next term, we're not going to worry so much about that coefficient right now. We're going to think about the a's and the b's. So we have a to the, we're going to go 1 less than n, so a to the n minus 1 power, and then the b we're going to go up from 0 to 1 here. So let's think about the next term. So we have coefficient we're not worried about right now. And then we would have a to the n minus 2 power. We're going 1 less again. And now we're adding on to the b powers. We're going to have a b to the second power. And then we're going to do that all the way up until our last term. And our last term is going to be when we have a to the 0 power times b to the n power, whatever that may be. We all good on that pattern? Okay, so now what I'd like to do is focus on how we come up with the coefficients for each one of these expanded binomials. And we're going to look at something called Pascal's triangle to understand what where each one of those coefficients comes from. And we're going to start off with we're going to make a triangle, and the very top is going to be the top vertex. And we're going to place a 1 at the very top. Right below the 1, on either side, we're going to place 2 more 1s. And what we're going to do is we're going to make 1s going down the edges of the triangle, and we're going to fill in the numbers that make up the actual triangle itself. And we do that by looking at the 2 numbers up above any one number. So if I'm going to fill in this space right below here, below these 2 1s here, we would just need to add the 1 and the 1 to come up with a 2 for that spot there. And the sides of the triangle, we're going to have a 1 and a 1 over here and here. So this is the first row. We call that n equals 0. This here is the second row. We call that n equal 1. This is the third row where we have n equal 2. So let's think about n equal 3 now. Okay, so I look at the 1 and the 2, add up 1 and 2, and that gives us a 3. 2 and 1, that gives us a 3 there. And then the numbers on the outside here, we're going to have a 1 here, and then a 1 over here. And that's for n equal 3. Now let's go to the next row. If I add a 1 and a 3, I'm going to get a 4, a 3 and a 3, that gives us 6, a 3 and a 1, that gives a 4, and then we have 1s on the outside there. So 1 and 4, that gives a 5. 4 and 6, that gives a 10. 6 and 4, another 10. And then a 5. And then we have a 1 on either side. So this is n equal 4. This is n equal 5. So n equals 6. Let's see that one. We got a 6, 15, 20, 15, and then 6 and 1 on outer sides. Let's finish up with one more, okay? We're going to do n equals 7. So we have a 1 and a 6 gives us 7. A 6 and a 15 gives 21. And then 15 and 20 give 35. Then we have another 35. Then we have a 21 here and a 7. We have 1s on the outer edges. So we could do this forever, right? Pascal's triangle will continue in this pattern forever. And we can use this pattern to come up with the coefficients when we expand a binomial. What I'd like you guys to do right now is to expand the binomial using the generalization that we just came up with along with Pascal's triangle. Why don't you guys try and figure out what a plus b to the 7th power is equal to without actually having to expand and multiply. Use the generalization along with Pascal's triangle. So here I've used the generalization so far. Now all I need to do is fill in the blanks using the row in Pascal's triangle. So somebody help me out. It was, you have a 1 there, and then 21, 35, 35, and 1. Okay, so you don't really need the b to the 0 power or the a to the 0 power, but sometimes it helps us in our pattern. So this works out really nicely when we just have an a and a b. But what happens when we have something like this? What are we going to do when we have 2x minus 1 to the 4th power? So we have 2x minus 1 to the 4th. And what we want to do is we want to think of the 2x as our a value and the negative 1 as our b value. So let's go through and figure out the generalization of how this should look. I'm not going to worry so much about the coefficients yet. I'll ask you guys what the coefficients should be in a second using Pascal's triangle. But let's go through. And we have the 2x represents the a, so that's a 2x to the 4th power, and then we have times negative 1 to the 0 power. That's our b, so negative 1 to the 0. And we're going to add that on to some coefficient, and then plus we have 2x to the 3rd power now, times we have b to the 1st power, plus some coefficient, and then we have 2x to the 2nd power times negative 1 to the 2nd power, and then we add, we have a coefficient, and then we have a 2x to the 1st power times negative 1 to the 1st, plus we got a coefficient, and then we have oops, thank you, to the 3rd, and then we have 2x to the 0 power times, we got a minus 1 to the 4th power. So what we need to place in these coefficient spots are the spots from Pascal's triangle. So we go all the way over to n equals 4, and we're going to place each one of these into those blank spots. A 1, a 4, a 6, a 4, and a 1. So a 1, a 4, a 6, a 4, and a 1. So let's simplify this and see what we get. We have a 2 times 2 times 2 times 2, that gives us a 16, and then x to the 4th. Negative 1 to the 0 is just a 1. So we have a 16x to the 4th. In the next spot, we have a 2 times 2 times 2. That's an 8. Times 4 is a 32, but then we have a negative 1 to the 1st. That's a minus 32x to the 3rd there. Next one we're going to have is going to be a plus, because we have the negative 1 squared, and then we have a 2 times 2 is 4, times 6 is 24, so we have a 24x to the 2nd, plus we have negative 1, negative 1, negative 1, it's actually going to be a minus, and then we have an 8 here, 8x, and then finally we have the 1 times 2x to the 0 is just a 1 times negative 1 to the 4th is a 1, so we have a plus 1 in the very end here. So I give you guys a total of 4 problems to work through on your own using our generalization and Pascal's triangle.